So let's talk about alkane first. Alkane is included to a homologous family that are classified into hydrocarbons. What is the general formula of hydrocarbons? The general formula is CN H2N plus 2. So what does it mean? If we know, let's say, a hydrocarbon has, let's say, 5 C's inside that the chain. So then we know that if the N, let's say, N equals 5, so it means the formula equals to C5H2 times 5, which is 10 plus 2, which is 12. CnH12. Okay, and if we draw it, CnH12 like this, we draw first the carbon chain, and then after that we complete it with the hands that hold the hydrogen atoms. Yeah, like this. Okay, and then if we name it, it means the name is pentane. Okay, now let's check. Is it true that the formula of the structure that we draw shows C5 and H12? Let's count the C's first. 1, 2, 3, 4, 5. So there are 5 C's. And then the hydrogen, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Correct. So it means that it's easy for you guys later to apply the general formula in order to find out the molecular formula of an alkane member. Now let's continue to the naming and also to the isomers. Okay, just now we already discussed about one of the alkane member which has the molecular formula of C5H12, and it is pentane. I'll draw it once again quickly. And then complete all of the hands with a note that every carbon has 4 hands. It is related to the valence electrons of the carbon, which is 4, the valence electrons, yeah. Okay, like that. Now, the structure that has the molecular of C5H12, it's not only pentane. It's not only pentane. Okay, we also have another structure for the one that has C5H12. For example, the one that has carbon as a branch. Then we complete it. Okay. Now, when we have this kind of structure, how do we name it? Okay, first of all, you have to find the longest continuous chain. The longest continuous chain can be horizontal like this, or it can be a little bit turning like this, also fine, as long as it doesn't break, so it continuously coming and then there is no break, yeah. So then it can be your main chain. Now in this case, because if we go turning like this, you will have a main chain of 4 carbons. Or if you go horizontally, you will also have a main chain of 4 carbons. So to make it easier for us to name it, we just use the one that is horizontal. And then we put the numbers, the one that is closer to the branch. In this case, number 1 is here, yeah, on the right instead of on the left. And then here number 2, number 3, number 4. So from these numbers, we know that at carbon number 2, we have this branch. And this branch is actually just like the structure of methane, but then with one of the hands attached to carbon instead of to hydrogen. So it means that as this branch, we don't call it methane, but methyl. Okay, so it means that the name of this structure is, at carbon number 2, you have methyl, so 2-methyl, all right? And then the main chain consists only 4 carbons, which is butane. So it means it can be 2-methyl butane. Now, if we calculate, 2-methyl butane also has 5 Cs, and it has also have 12. It also has 12 hydrogen. So this is also with the same molecular formula, which is C5H12. All right. Next, is there any other possibilities of having another structure which shows C5H12 molecular formula? Yes, there is, which is like this. When you have the carbon branches, okay, at the same carbon. So it means here, you draw the hydrogen first. Okay. And we find where is the longest continuous chain. 1, 2, 3. Yeah. So we number it. Okay. 1, 2, 3. So at carbon number 1, you have methyl, but not only 1 methyl, but 2 methyls. Okay. So it means the name of the structure is 2.2. So it means at carbon number 2, okay, there are 2 methyl. So it means dimethyl. And then the longest continuous chain as the main chain shows only 3 C. So it means propane. So it means the name is 2.2 dimethyl propane. It has also the same molecular formula, which is C5H12. Okay, now it means these are different compounds, different structure, but they all have the same molecular formula. This is what we call by isomers. Isomers are different compounds that have the same molecular formula. All 3 of them have the same molecular formula, which is C5H12. So that have the same molecular formula, but different structural formula. Okay. So these are all different in their structures, but they are all the same in their molecular formula. Okay. Now let's continue with a specific reaction that alkanes have. One of them is cracking. I think I'll just do this. I'll take both, yeah. Now here, write the formula of Dodecane. We can do that, but then here P is propane. P is propane. Q is propanoic acid. Okay. R is butene. So Q is propanoic acid. Now in this case, we haven't got any clue of the structure, but of course we can always study in other videos later. R equals to but1in. And then S equals to propan1ol. T equals to methyl butanoate. We can also learn about this in other videos. And the last one, U, is an alkene, but has 3 members, so it's a propene. So the one that can be the product of the cracking of the decane is propane, but1in, and then propene. Why is that so? Because the product of cracking are also hydrocarbons. So propanoic has the oxygen and alcohol has the oxygen. Methyl butanoate also has the oxygen. So it means they cannot be the product of the cracking. So again, the product can be propane, but1in, and propane. Now we'll return to the previous picture, which is about the cracking of Dodecane. Okay, wait. Cracking. Oh, this one. All right, yeah. Let me write down again so that we will remember. P equals to propane. And then, oh, just now. P is propane. And then R is but1in. And then U is propane. Yeah, okay. So it means R is but1in. And U is propene. Okay, write the formula of Dodecane with 12 carbons. So it means C12, H2N, which is 24, plus 2, so 26. Give the letters of all the organic compounds P to U that can be formed when Dodecane is cracked. So it means you can have P, propene, and then you can have R, but1in. Oh, P is propane, R is but1in, and U is propene. Now, what is actually the, let's say, the formula, yeah? The formula, the products of the cracking can be mixtures, okay? But then they should be like this. So if a large or a long chain, a large of alkane member is cracked, okay, then the product would be an alkene, which has double bond or unsaturated, plus, okay, plus alkane, smaller, or we can say small molecules of alkanes. Smaller molecules of alkane. So that's why here it is impossible to have the methyl butanoate as the product of the cracking, yeah, of Dodecane. But then it's possible to have propane, to have but1in, and to have propene, because these two are members of alkene. which is a hydrocarbon homologous series that have unsaturated double bond. Yeah.